in trouble with one particular topic, it's probably better to go to YouTube and go pre-calculus, difference quotient, right? And then there'll be 10,000 nerds doing problems. Pick the one that doesn't put you to sleep, right? So this is 2.1, number 85. I'm just going to start it. I've got f of x equals 1 over x squared, right? We're going to be constantly looking at Desmos. As soon as I give you a function and you don't know what it looks like, guess what? Go to Desmos or your calculator. You do have the choice of using a handheld calculator during a quiz or test. Desmos is a lot clearer to me, okay? So Desmos.com, start graphing. And I want to put in this, f of x equals 1 divided by x caret right to the second. So there's my function. And remember, I'm gonna pick 2 points on this function, right, to get a secant line. Yes, that making sense? Desmos recognizes x as every x variable. What's the domain of this, by the way? Everything but 0. What's the range? Yes, right. Everybody see that? So I can't divide by 0, but all the other x's are fine. And then 1 over any number squared will never be 0 or negative, right? So it's got to be everything above 0 in the y's. So we're going to put 2 points on this. Let's pick the first one as a, comma, f of a. I use that f of x notation so I could just call on this using that function notation. And it says add slider. And so I can now move that point on my curve by moving the slider A, or I can actually drag the point. Right? You with me there? Everybody's able to create this. And I want you kind of sitting at the same computers because we know they work right now, right? So laptop is fine now, but like I said, when you take a quiz or a test, I want you on the school computer. Okay, hey, come on in. Sorry. You have a little exercise? Yeah, I know it's hot too, right? At least I didn't pick a day it's raining to move. You can thank me later. Yes. To put the 2 at the top? Oh, the up arrow. Yeah. You also have a library of functions down here in the keyboard. So you can see you could use one of these to put in, but I find it's easier just once you know the shortcuts just to type it normal. Did you get it? Yeah, nice, good. We want another point. What should I call it? Who's got the big brain today? I just watched Pulp Fiction again for the 50th time. You ever see that movie? Look at the big brain on Brad, the metric system. So what's my other point? You remember? Well, when you're doing this secant, this difference quotient, you're doing f of x plus h, right? I can't use x because Desmos understands it as every x. So I'm going to pick a specific x, and I'm going to call it a plus h. So a plus h, comma, f of a plus h. And I add slider h. So at this point, my x values are how far away? On the 2 points, how far away are my x values? 1, exactly, it's the h. H is the distance between the x values. So if I move point A, you see the other point, it stays 1 away, right, from left and right. Yes, you see what I mean? Again, I can change h to I don't know, about 3. And if I move my first point, the other point stays that distance away. How are we doing there? Are we okay? What's my slope here now? How do you calculate the slope? So look at what I have so far, right? I've got 2 points on here, right? One here, that's a, f of a, yes? And the other point is a plus h, f of a plus h, yep. And remember, this distance between the two is h, right? Good, so how do I get the slope here? F of a plus h minus f of a all over h. This is my difference quotient. Difference meaning subtract, quotient meaning divide, right? So subtract, divide by h, right? So I want to put that in into Desmos. So f of a plus h, you're doing this with me, right? Minus f of a. We're going to use Desmos every class. Divide, highlight the whole thing, hit the divide symbol, divide by h. And you see it's calculating my slope for me. How are we doing? Everybody there? Everyone okay? Yes, Eli? Yeah, can I see what you got? Oh, you okay? Help each other is great. If you can help each other, that's great. So you okay? You need that second point now? Can you see it? What do you think? This room's better, isn't it? Like if you're bored, you can press the left, right? Yeah. Okay. You got an F slider somehow. Get rid of that for me. Get rid of. Oh, there they are. Nice. Yeah. Okay. A comma F of the A. Yeah, no, no, A comma F. Parentheses. Open parentheses. Good, no, yeah. Good A. Close parentheses, close parentheses. And add slider A. There it is. Okay, so try and catch up to me. I'll try and put a little delay in before I do this next thing. But I picked 2 points, right? Now, when I'm doing this difference quotient problem, why am I keeping in this f of x plus h minus f of x all over h? And now I'm doing a f of a, because when I'm doing the difference quotient, I want it for any x. Right? In the homework, I'm saying, hey, use the formula f of x plus h minus f of x, right? And here, I'm picking a specific point. So it's a subtle difference, but it doesn't matter if you get it or not yet, but you will. What's my equation of my line? What's the equation of my line? Well, we learned y minus y1 equals m times x minus x1. This is the point slope equation of a line. And of course, we already know what x1 and y1 is. It's the first point we picked, right? So we're going to put in y minus f of a equals m all times x minus a. That's my next line I'm putting in to Desmos. Y minus f of a equals m times quantity x minus a. And there's my secant line. So when you're doing a homework problem, like the first two, it's nice to create this again. And it doesn't look on your phone as well, right? If you're taking a quiz test, you're going to use the school computer. So it's nice to, and you can, by the way, you can sign up, register a username, and then save it again. It is free. Okay. So now we got our secant line. All right, let's get back to the homework problem. Anybody need another minute here? Anybody need another minute? Anybody need help? Need a minute. Okay, no problem. I'm Polish, I'm not Russian. Not in a hurry to get anything done. Joshua here today? No. Francisco, you here yet? Okay, we good? Yeah, question. Yes. Right, so that's my secant line. What is m? It's the slope. Hey, sorry, hey, welcome. Sorry if you got forced to exercise. So, right, m is the difference quotient. It's giving me the slope of the secant line, right? How we doing? We okay? All right, here we go. So the slope of my secant line is going to come from, look at what I'm putting in. Do you see that my function, the first time I wrote my function, I wrote empty parentheses squared, 1 over empty parentheses squared, right? Because I want to fill that in. I want to make sure I have empty parentheses. And then fill it in with x plus h. You with me there? So again, looking at my green piece here, this is my original function evaluated at x plus h. I'm using a on Desmos, but in general I'm going to use x. So the original function evaluated at x plus h. The key is start with empty parens. Right? If you just see that, you see 1 over x squared. See what I'm saying? I see 1 over x squared, but I fill it in with x plus h. Minus the original function all over h. This now is my fraction version, right? And if you remember what I said, we're only going to do 3 things. We're either going to factor, we're going to use a conjugate, or we're going to use a least common denominator, or a common denominator. Notice that my only interior denominators, or if I do this, all my interior denominators, not the big denominator. If I take them all and multiply them together, I'll get a common denominator. So I want to use as my common denominator x squared times x plus h squared. And I'm going to multiply that. sorry, over itself, so that I'm only multiplying by 1. Yes, you with me? Yes, no? I see a couple of nods. I'm going to distribute that in to numerators. I'm going to distribute into numerators. I'm going to write my original in black and my new piece in another color. So my original in black, original in black. And the distributed piece in this, whatever it is, purple, whatever. What color would you call that? Violet? No? What is it? Make sure you're with me here. So I get my fractional piece that's got fractions within fractions. When I see that, I need to clear, I call it clearing denominators. I'm going to multiply by the common denominator divided by itself. Right? The common denominator divided by itself. I distribute that into numerator. So it goes to that numerator, goes to this numerator, goes to the h. That's also a numerator, right? H over 1, right? I change my color to red. How are we doing here? Say again? Just stay here. Yep. We okay? Nice. My x plus h quantity squared cancel, and my x squareds cancel. And then I'm not in a rush. I'm going to rewrite x squared minus quantity x plus h all squared divided by h x squared x plus h quantity squared. I'm taking my time. Every step I do is a super easy step. How are we doing? We okay? Now, upstairs, I'm going to simplify, and that means x plus h times itself, right? And this is our favorite 4-letter F word here, FOIL. So I get x squared plus hx plus another hx plus h squared. And yes, it's taking a lot of time, it's taking a lot of paper, but I don't want you skipping steps unless you're getting things right. If you get things right, I don't care if you skip some algebra, but for the most part, I want you doing one little step every time you do something. How are we doing? I'm going to distribute that negative, right? But what's going to cancel? Do you see it? What's going to cancel here? Yeah, the x squares. And remember, I had said every term without an h in it, without a factor of h in it, better go away. So look at what I have upstairs now. I have negative hx. Oh, sorry, negative 2hx, right? There's two of them. Minus h squared all over hx squared times x plus h quantity squared. We okay there? Make sure we're okay there. What were the three things on my list? A conjugate, a common denominator, and factoring. So you can see here, I can factor out an h here, right? I can factor out an h. In calculus, we want h to go to 0. We want those 2 points to become what? We've got 2 points on the curve, right? We want the two, if h goes to 0, what happens to the 2 points? What is it? No. Think about it. When the distance between the points becomes 0, what happens to my 2 points? They become the same point. Calculus is all about how can I calculate the slope at a single point? We know we can't, right? So we learn something called limits in calculus first, so that we can then find the slope at a single point. So now my h's cancel. And I finally have my difference quotient, right, which we say is the slope of the secant line, negative 2x minus h all over x squared times x plus h quantity squared. Pretty nasty problem. Let's see what it does for us, right? So looking at Desmos, I think I like the first point at 1. Looks like I have the point 1, 1 there. Do you agree? So if you can move A to 1, and maybe H to a half. Nah, it's not that good. Yeah, it's not horrible. What about H is 2? Sorry, H is 1. Yeah, I like that one. So I got A set at 1 and H set at 1. Right? You with me? So what do I actually have for points here? If X is 1 and H is 1, right? Just because I chose them, right? What do I get for my secant slope? Negative 2 times what? 1 minus 1 all over 1 squared times 1 plus 1 quantity squared, right? I plugged in every x as 1 and h as 1. So I get negative 3/4. Negative 0.75, right? That's the same thing I have on Desmos. Notice what I did. Did I plug in? Help someone get a scholarship, write up a letter. Look what happens. She was in my pre-calc class, in calculus class, in 2008. Just graduated from the Temple. So, the top student. Now, look at what this difference quotient did for me, the slope of the secant line. Did I need to know any y values at all? All I need to know is one x and how far away is the other x, right? A distance of h. Let's just double check what we have here, right? So meaning y1 is when I plug in 1 to my function, right? So 1 over 1 squared is 1, right? Yes, you with me? On Desmos, I can see that point 1, 1 right there, right? My other point is 2. It looks like a quarter, right? 2 comma a fourth. Do we agree with that? Y sub 2 is f of 2. That's 1 over 2 squared. That's 1/4. Yes, you with me? So what did we do back in 8th grade or 9th grade or whatever grade it was, right? We got our slope with 1/4 minus 1 over 2 minus 1, right? 1/4 minus 4/4 over 1, that's minus 3/4. So what I'm kind of saying is this secant slope, this difference quotient, is getting me that slope faster. Yes, it took me a lot of work to get the difference quotient, but it's gonna do wonders for me in calculus. Okay, so that's why we're putting it in pre-calc. Just trying to get you ready for calculus. That's all I care about. Anything else you want me to do? Is that Brian asked me to do that one? Yeah. Is that the help? Yeah. How we doing? We okay? Beautiful. Let's go back to our transformations and translations, yes? So what was the main problem we were doing last class is we wanted to say, hey, let me shift my x squared function by something, right? So I want to show that f of x equal to x squared plus 2x plus 4 is a translation, just want to move it, right, of y equals x squared. And we're going to do that using complete the square, right? So I think I had said did I say don't write it, or did I say I'll put the details in the next class? Didn't I say something like that? So I kind of want to give you a step-by-step for completing the square, okay? So I want to isolate ax squared plus bx. I'm going to group those first two terms together, right? Factor out a if a does not equal 1. So if it's -1, if it's 2, if it's anything, factor it out. The problems I'm doing right now, I'm going to keep a as 1 for now, okay? And you'll see why in a second. Find k, the new coefficient of of x, the new coefficient of x. I'm just trying to not confuse it with ax squared plus bx, right? You know what I'm saying? Ax squared plus bx plus c, right? Remember that quadratic? I'm trying not to confuse this new number with b. I'm calling it k. I like to say, if you see k, you'll be fine. If you don't, if you see k. It's a crude joke, I know, but I want to do what then? Find half of k and half of k quantity squared. Like, this is something I would put on my formula sheet. If I didn't practice enough, I would want to have some kind of reminder of what the hell to do, right? So you're working on that formula sheet right away. You can use it on the very first quiz. You can listen to music on the quiz as long as it's on your phone, not on a laptop, and the phone is away and no one else can hear it. Okay? Same on a test. I want to add half of k quantity squared inside and subtract it outside. If you kind of remember me doing that, right? And then getting rid of it, making sure it canceled there. So x squared plus kx plus half of k quantity squared always factors into x plus half of k quantity squared. This is it's strange. I'm giving you directions to my house, and I say, hey, when you see the building with a big yellow M on it, turn right, right? And you have no idea what I'm talking about until you get there, and it's a McDonald's, right? You know what I'm saying? So the directions aren't going to make sense until we start doing the problems. So there's my step by step. You will complete the square in calculus class. So why am I doing it now? Because the only thing I care about is getting you ready for calculus. We're really trying to rename this course Pre-Cal 1. It used to be Pre-Calculus for Calc 1, Calc 2, Calc 3. So what I'm doing to try to make the course easier is I'm ripping out material for Calc 2 and ripping out material for Calc 3. I'm only teaching you material for Calc 1. So that, one, it makes pre-cal easier, and two, you will do really well in calc. That's my goal. That's the school's goal, but really that's what I'm trying to do here. Okay, let's go back to our problem. Are we okay? Are we ready for this? Yep, sure. Yep, no problem. Even if I was Russian, I'm not Russian. That's funny. I'm Russian, but not Russian. Yes. So, back to our problem, using my step-by-step. I want to isolate x squared plus 2x and leave the 4 on the outside, right? I have to look for my leading coefficient of x squared, but that's 1. So I don't have to do that step. I don't have to factor that one out. I will do one where I have to factor that out later, okay? Now I have to find the coefficient of x. What is it? What number is the coefficient of x? 2. And half of that is 1. And of course, 1 squared is also 1. I'm taking this piece and moving it in here, right? So I'm adding 1 here. But I can't add 1 and keep equality. I have to add 1 and subtract 1. So I'm going to subtract that 1 over here. Look at what that piece in parentheses is now, right? The piece in parentheses is a perfect square. That's what we're doing, completing the square. We're making part of it a square. And what is it? Can you remember this from Algebra 1? 1 what two numbers multiply to 1 and add to 2? You remember that? Just say yes. Yep. So I get x plus half of k quantity squared. There it is. Watch this on Desmos, okay? We ready? We okay here? First of all, any questions? Everybody's in a good seat? You can see everything? Yeah? All right, here we go. Watch this. So again, if you log in to Desmos, you can save files, right? So it's a good thing to do if we're working on something and you want to look at it later. It's also a good idea for you just to try it later, right? And see what happens here. So watch what I do here. And I want you to type it with me. I've got f of x equals, I want to do x minus h quantity squared plus k. And I want h and k to be sliders. Depends on market close. Look at where the center. This is called vertex form, by the way. You see the vertex is at what point? 1, 1, right? In fact, better yet, it's at h comma k. Let's put that point in. H comma k. Now, as I move things, look at that vertex stays there. The vertex is h comma k. I want h to be 0. And I know this might be confusing with the other h and the other k and all of that, but it's part of math, sorry. Look at where it is when I let h and k be 0. It's some other function, right? 1, 1, remember the square, 0, 0, 1, 1, right? So this is some other function. What was my value for h? In my problem, what's my value of h? Plus 1, right? And my value for k is 3 here, yes? You with me? So I want to move h to 1. Oh, I'm sorry. I want to move it to minus 1. Sorry. Right? Do you agree with me? Right? I probably should have said x plus h, but it's fine. Right? Because I had x plus 1, right? But I want h, I wanted x minus h, so it's got to move the opposite way. If it's interior, it moves inversely. And then I'm going to do plus 3, right? So k is plus 3. So you see, it's just that mother function moved. If I look at the table for the mother function, right, y equals x squared, and f of x equals x plus 1 quantity squared plus 3. Some numbers on my table, if you remember, minus 2, if I square it, I get a 4. Minus 1, if I square it, I get a 1. 0, if I square it, I get 0. 1, I get 1. And 2, I get 4. And now I can do my new table of the daughter function with all x's doing what? How should I change my x's and how should I change my y's? Other way, subtract 1. It's always, if it's an interior piece, it acts inversely. It's weird. So I want to subtract 1, minus 3, minus 2, minus 1, 0, help me, minus 3, minus 2, minus 1, 0, and 1, right? And then do what with my y's? Add 3. So interiors are inverse, exteriors are direct. Interiors do the opposite, exteriors do what you think. So this one's going to become what? 7, 4, 3, 4, 7. You with me? Let's verify. Look at my new piece here, right? And just look at the vertex. Where is it? It's at minus 1 and 3, right? Look at my old vertex from the mother function, and look at my new vertex from the daughter function. How we doing? We okay? All right, that was last class. Let's now talk about transformations. Remember the car that becomes the robot. We're gonna manipulate the function now. We're gonna stretch it or we're gonna compress it. Okay? So this is still section 2.5. But we're talking now about compressions and stretch. A stretch or compress. So here's my mother function, y equals square root of x. And here is my compression, y equals 2 square roots of x. Is that an interior 2 or exterior 2? Is it on the inside of the function or is it on the outside of the function? Exterior, right? It's on the outside. So what it's going to do is it's going to affect the x's or the y's. Other way, right? The outside is f of x or y, inside is x, right? Domain in. So what it's going to do is it's going to take my function and stretch it this way. And so if I say multiply by 2, all my heights get multiplied by 2, right? So in on my mother function here, we had a bunch of points, right? We had 0, 0, 1, 1, 4, 2, right? Square root of 4 is 2, right? And then what's my new function going to look like? The x's are going to stay the same, but the y's are going to get doubled. So 0, 2, and 4. You with me? Good. Let's see if we can see what's happening on Desmos here. So I want to create my function with a slider. I'll use a. So a square roots of a. Sorry, square roots of x. A square roots of x. So there's my mother function. If a is 1, you agree? It's just square root of x, right? I want to show that if I change a to be larger, the graph goes up. It gets stretched up, right? It's no longer the same shape. It's now, right, it's transformed. And if a goes smaller, it crunches it down. And it's hard to get this. It's hard to figure this particular piece out. But you can see as I make a larger, it's stretching out the graph in that direction. At least I think it is. Right? And if I make a smaller, it's crushing it down all the way to 0, of course, and then we're negatives, and it's flipping it upside down, right? So, but a is 1 is the mother function. Let's see if I can do this, and then if I get it done, I want you to try it real quick, okay? I want to pick a point on this curve, and I want to see that the x value stays the same as I move. You know what I'm saying? So I got to use another letter other than A now. Sorry. But let me plot the point B, comma, f of B. Don't do this yet. Let me make sure it works for me. And I want to make that a slider. And now all I'm hoping to see is that that point just moves straight up as I move A up. Right? Is that making sense? So here we go. Yes. So when I'm multiplying by something on the exterior, I'm either stretching or compressing the function. Right? All right, see if you can copy that and play around with it and see what's going on. How are we doing here? We're good? Say again? By the way, if you ever ask me for a recommendation, I need 30 days. I write so many recommendations that I'll have some weeks I'll have 7 or 8 to do, and then I can't take another one, right? So think about that. Do that for all of your professors, please, when you're going to ask for a letter, whether it's for honor society or an internship or to transfer to university. Give us some time, please. How are we doing here? We okay? Good. I got one more transformation and then reflections to do, and then we're done with this section. Okay. So I want to now put this multiplying variable. Notice when I was doing the horizontal shifts, right? I'm adding and subtracting, and now when I'm doing these compressions and stretches, I'm multiplying. Right? You with me? So how'd it go? Everyone get the sketch written? You see it? Nice. So I want to do the same function, but I want to put my slider A on the inside. I again want to add my point B comma f of B. I guess I could have left all of this, right? I didn't have to retype it, but too late. And now I'm asking you, don't do it yet. Wait for me. Where is that point going to move? And by how much? Remember, when it was on the outside, it's a direct. It says make it bigger, right? Make it smaller, make it smaller. But on the inside, it's supposed to be inverted. Where is that point going to move? As I move A bigger, where is the point going to move? Where? Lower? What else? Who else? Well, if I make A2, right? If I make A2, the number 2, yes? It looks like I'm doubling X. But you know, in here, it's going to be inverse. So what am I actually doing to X? Cutting it in half. So this thing is going to compress. As I make A bigger, the graph should compress smaller. If I make A smaller, the graph should be stretched. It doesn't, it's kind of, and if you take physics, if you engineers, when you take physics, a lot of it doesn't quite make sense when you first learn it, but you got to just get your hands on and do it. So let's see what happens when A. Oh, damn it! It didn't work. It's supposed to do something else. So I got to think. Oh, no. It's supposed to compress it. It's supposed to move it left. I don't know what I'm doing wrong. But look at the table here. So if I have y equals square root of x, and I gotta work on it. I have to bring it back to you next week. 0, 0, 1, 1, 4, 2, and then I will look at y equals 2x on the inside. I guess this is kind of right. This is really, I gotta work on the sketch. I'll think about it. But this is really square root of 2 times square root of x. So again, it's an outside up and down type of thing. But I want to look at my table, right? And I'm not changing anything on the outside, so I'm saying the y values should stay the same. But what are the x values now? I'm multiplying by 2, but that really means divide by 2. So I get 0, 1/2, and 2. So all I'm asking for is when I move this, forget about the graph not being correct, right? Do you see the point 2, 2? So that point that used to be 4, 1 has now moved to 2, 2. So my x, again, that thing's on the interior. My sketch is not right yet. Okay, I gotta think about it. You could think about it too. I want to see that x value moving to be compressed in the x direction. Right? But I have to think about how to do it. It's not obvious to me. All right, let's take a little break. Come back in 6 minutes, 3:10. If you want to go check the line downstairs, that's fine if you do that now. Maybe it's empty and you could not miss any class. There's I think once a month there's a free food giveaway, fruit, vegetables. It's available to you. I think it's available to the community. So it's downstairs if you want to go look. right, here we go. There's some dead space in the recording. I forgot to turn it off. So what's my mother function here? Yeah, x squared is the mother function. And you see here I have this crazy thing happening here where I'm multiplying on the outside, right? Multiplying on the inside, shifting left or right, shifting up or down. So this thing is kind of my ultimate transformation tool here. This is a program called Sketchpad. It's not free, but I'm asking you to maybe play around with this on Desmos and create a free one. So let's go to home, and you can see here I've got my mother function. You see my square, 0, 0, and 1, 1, right? I want to just adjust things. So for example here, if I multiply this by 2, right? You see my square now has a side of 2, right? You see what I'm saying? If I multiply this thing by a negative, it moves everything down. But you can see what's happening to my square as I do this, right? So so in this particular piece, right, I've just let H and K and A and B do whatever they want. Remember what A is doing. A is multiplying, it's stretching it up, right? So it's stretching it up. B is compressing it in the X direction. So you see that's what was supposed to happen before. I haven't figured it out on Desmos yet. And if I move H to the right, it moves my square to the left. H is the horizontal shift. If I move my H left, it moves the box right. And then K will just move the box up or down. But the idea is that if I can move the square, I know where the function moves. Now, it's all kind of a little not too important, because what are you going to do when you get a graph? You're going to put it in Desmos or put it in your calculator. That's the first thing you should do, right? And then we can figure out what the transformation is. Right? So, I think the only thing that's a little bit different are the reflections, so I want to just talk about that real quick. So if, for example, I have y equals square root of x, there's that piece. If I reflect on the outside, it's going to take my y values and move them down, right? Do you see that? It's making all my y values be opposite. So this is a reflection about the x-axis. If I look at y equals the square root of negative x, if I put that reflection interior, right, it's going to do this. So this is a reflection about the y-axis. So just by knowing the mother function, I can manipulate that table, right, depending on, remember, if I did it last time, I moved the x's first and then I moved the y's, right? So I want you to do homework in 2.5. I like all of the problems in that, all of the odd problems, but I want you to turn in number 45 and 53. So we have 1, 2, 3, 4, 5, 6, 7 problems to do. 7 pieces of paper stapled. Yes? Hello? Can I just get some acknowledgement there? Thank you, thank you. 7 pieces of paper, 7 problems. Continue on the back if you need to. Turn in perfect works of art for me, okay? Yes, I'll do it all in one page, yeah. Um, so homework, yep, homework due Monday. Let's see, today's 19th, 26th, right? 9/26. So I had problem in section 2.1, number 85, right? Yes, yeah. And I want you to get me two slopes using the process that I did, right? Does that make sense? So I'm going to ask for a slope like middle school, y2 minus y1 over x2 minus x1, and a slope using the secant, right? With the same f of x plus h, right? Minus f of x all over h, right? So yeah, is that making sense? You're going to find me the secant line and then plug in the x and the h, right? You're going to find me the secant slope formula, the difference quotient, and then plug in the x and the h. Okay. In 2.2, I asked for number, don't tell me, number 27, and I'm adding part G. In 2.2, number 27, A, B, C, D, E, F, do all of that. You probably have to finish on the back and add part G, which is the sine table. Say again? Yeah, so I did one last. If you want me to do another one, I will. You got it? Yeah. Yeah, it's not in the directions. I'm adding to the directions. Yeah. Yes. So what I want is that you find the critical values, right, which is when the numerator is 0 or the denominator is 0, and then you pick points in between the criticals. So for example, if it was like f of x is x plus 2 over x minus 3, right? The criticals are what, negative 2 and 3? Yes, you with me? And so x plus 2 is a factor, x minus 3 is a factor, f of x is the whole thing. And I want to test, this is kind of a number line here. I want to test in between, so how about 0, right? To the right, how about 7? And to the left, how about negative 5? So I'm testing the sign of the factors at any place in between the criticals. Does that make sense? Right, if we look at the one I did, I think I did one on day 2. Yeah, there it is. So you can tell here, what are my critical values? 0 and 2, right? And so 0 and 2 are separating my columns. Do you see that? The factors, the numerator factor and the denominator factor, are separating my rows, right? And so I tested negative 1, which is left of the first critical value. I tested 1, which is in between the critical values, and 7. And in fact, I can do anything, right? Remember, because I even know what the curve looks like, right? And so I'm just figuring out what sign. If I put negative 1 into 2x, it's negative 2, but all I care about is it's negative. If I put negative 1 into x minus 2, it's negative 3, but all I care about is it's negative. Negative divided by negative is positive, so the function is above ground there. Sine table, yes? The next one problem is number 23, 2.3, number 73. 2.3, number 73. And I did one just like it at the end of last class. Then I wanted 2.4, two problems there in 2.4, 27 and 43. And I'm asking for a graph and a domain and range. I forgot already. Gosh, 27 and 43. And then 2.5, I just added number 45 and 53. And probably give me a table. They asked for a graph, but give me a table too. And I'll show you what I mean, okay? So this is the homework that's due Monday. 7 problems, 7 pieces of paper. Name at least on the first page. Should give me the section number, the problem number. Show your work. Make it look perfect. Yeah, exactly. You're going to pick some. Try and pick vampire points, right, where it's hitting crosshairs, so that you don't. I mean, I don't care if you pick fractions, but fractions are like family. We don't like them. I mean, we have to deal with them, but it's nice when they go away, right? Don't you agree? When family goes away, you get your remote control back and that kind of thing, right? All right, let me show you something like I want in 2.5. So 2.5, I'm going to give you 2 functions. If you can see, number 45 is a quadratic. It's a mother function x squared, right? You with me there? Number 45, can you see it? So number 45, you see it's a mother function of x squared. And number 53 is a mother function of, where'd it go? Oh, it's over here. It's a mother function of what? What's the mother function there in 53? Hello? Can you hear me? Square root of x. Yeah. So, like in 53, I want a table, right? So it's 2, that's 2, sorry. So 2.5, number 53, starts with my function as being 2 square roots of x, I forget already, x minus 2, all plus 1. So my square root function, right, we had 0, 0, 1, 1, 4, 2, right? Just like PEMDAS, you remember PEMDAS? Please excuse my drunken Sally. We got to kind of start on the interior, parenthesis, right? So I can look at the daughter like this, right? That's the daughter, yes? You with me? What does it change? The what? Yes, so it changes the x's, right? That thing I'm doing is on the inside. It's going to change the x values. So my y values are going to stay the same, and I'm going to add 2 to each of my x's. You with me here? And then if I look at the granddaughter, now what am I doing? So notice this is the daughter of the daughter, right? So the original daughter is now the mother function. But what am I doing now? You score? Yeah. Beautiful. What'd you get?
Corn, cauliflower.
Oh, great. Corn on the cob? Beautiful. Cauliflower?
Apples.
Oh, right. Nice. If anybody wants, is there stuff left? Is there stuff left?
Yeah.
Anybody want to go bring home a special? It's a good night for corn on the cob, if you ask me. What did I change here now? From the daughter to the granddaughter, what did I change? Did I change something on the inside? No. So the x's are going to stay the same, right? But I'm doing what to the y's? Multiplying them by 2. So I get 0, 2, and 4. Notice that I'm changing the x's here. I'm changing the y's here. There's one more. There's a great-granddaughter, right? Do you see it? The great-granddaughter says take the granddaughter as the mother and then have the child plus 1. And where is that plus 1? What is it affecting? It's outside. It's affecting the y's, so the x's stay the same. So what happened to the y's? Add 1. Right? That's what I mean by the table. So I got this complete list of homework now, due Monday. It's all here. 7 problems. Yep. Yes. No, I want to graph 2. Follow their directions and give me the extra pieces. How we doing? We okay? Yep. That's up to you. I personally like to go mother to daughter to granddaughter. I like to do that until I'm real sure about what's going on. You certainly could just, you could just copy the table from Desmos, right? It's kind of nice to see this table on Desmos, right? So let me show you that real quick, right? Are you still copying? Okay, I'll wait another minute. Nice, thank you. Anybody else still copying? Cool. So it's kind of nice to see this table. Just notice that in my final table, I want 2, 3, 6, right? Okay? So in Desmos, I had, it was 2 square roots of x minus 2 escape plus 1. And if you watch me here, I'm going to click on the gearbox and then click on the table. And what did I have? A 2? And then what? What was it? 2, 4? 2, 3, 6, yes? So 3, 6. 2, 3, 6, 1, 3, 5, yes? There it is, 2, 3, 6, 1, 3, 5. Right? Is that making sense? Nice. So, I mean, this is why I'm so happy we moved here. I know you might be still a little pissed at me for today, but this thing is so powerful compared to that stupid dinosaur that we've been carrying around, TI-83, 84. It's like a Celosaurus, like a flip phone. This thing is really going to help us connect, okay? All right, let me take one more. I want to take attendance, and I'm going to take a look at one more thing here. We get to have some fun next week. This chapter 3 is, I think it's fun, a lot of fun. Of course, I'm a nerd, so I think this stuff is fun. But let me do a transformation. Let me do one more transformation of x squared. Not a translation, a transformation of x squared. and see what happens, right? So this will get a little bit nasty, so just be patient with it and go use the step by step and use the calculator Desmos to help you secure your thoughts on what the hell's going on, right? So I want to show f of x equal to 2x squared minus 4x plus 3 is a transformation. So not only am I moving it, I'm also stretching it or compressing it, right? Of the mother function y equals x squared. Now you should already be able to tell me that this is a stretch or a compress. Is this a stretch in the y or a compress in the x? Stretch. Because what are you seeing outside of the mother? Outside of the mother function? The 2. So I'm taking the mother function and multiplying it by 2. So that means stretch it up. So this is going to be, yes, question. Yes, but multiplying inside is really dividing inside. Yes. So they both look like multiplication. But it depends on what you're doing it to. You're doing it to the y values and you're doing it to the x values. So I can see the mother function. I already know it's going to be a much skinnier version of it, right? It's going to be stretched out skinnier, right? And then it's going to move somewhere left and right, that kind of thing. All right. So what's my process? What's the first step? Do you remember? Group, right? Group, yes? Group the first two terms together, the x terms, right? Leave the constant outside. Factor the leading coefficient if it's not 1. What is my leading coefficient? 2. Factor it out. So what do I get now? X squared minus 2x. Yes? You with me? Next step, find k. What's the value of k? Negative 2, the coefficient of x. What's half of negative 2? Negative 1. Square it, and I get positive 1. I'm going to add that on the inside and subtract it on the outside. What the hell? What the hell? What the hell are you doing, Robert? I took this thing I found and I added it on the inside, but really, what number is it? Right? 2x squared minus 4x plus 2. So I have to get rid of that new plus 2. I have to, right, subtract it. Does that make sense? Wait till I get a negative 1, then you're going to... Eli, no? You see in black, 2x squared, there it is, 2 times negative 2x, negative 4x, plus 3. But now, all of a sudden, I have 2 times 2. That's 2 more. I have to get rid of that 2 more to keep it equal. What do I get now automatically with those parens? What am I asking you to remember here? This is automatically x plus half of k quantity squared. Here's my table for the mother. I think we can go right to the great-granddaughter here. Let's see if we can do it. What, if anything, is happening to x's? what's happening on the inside here in my new function? Subtracting 1, right? Which means adding 1. So my x's become minus 1, 0, 1, 2, and 3. Nothing else is happening on the inside. You know what I mean? Inside the parens, right? But now two things are happening to the y's. First, I'm going to do what? Multiply by 2 and then add 1. So 9, 3, 1, 3, 5. I multiplied my y's by 2, right? That's on the outside. And then added 1. The following sentence. Multiply, divide, and 4. So 2 times 4 is 8 plus 1 is 9. Times 1 is 2 plus 1 is 2. Right? Nice. Let me take attendance. So no Joshua here, right? Joshua's missed every class. And no Francisco, right? Did Francisco come in? Oh, hey, did you get the form? Oh, good. Right after class, okay? Thank you. Nice. So I'm going to ask, does anybody want to move their seat right now? You're comfortable where you're at? Because I'll just ask you to sit in the same seats next time, so until I get everybody. And I promise I will get there soon. It really takes me when I start handing papers back. I need that kind of thing to make things click in my head. So bear with me. Again, I apologize about any extra exercise I made you do today because of the room change. Do you feel how powerful Desmos is when we're doing these things? Even if you're a little bit, I don't know what's going on, right? You can still see it's different. It's different to have that tool in front of you when you're learning math. I'm trying to get all my calc classes like that. Right now, this semester, I have 3 classes all in this room. Calc 1, and your class pre-calc. And we're doing everything on Desmos. Like if you transfer to UMD, they don't let you use a calculator at all in math. But it doesn't mean when you're practicing, you don't use it. When you're practicing, use it. If I give you a function and you don't know what it looks like, graph it. Okay? And hopefully by the time we get to pre-cal, we'll be able to look at any graph and know what it looks like without a calculator. That's our goal. Where's John? John is out today. City? Out? Really? Okay, everyone else is here. Eli's here. No, Josh is not here. He doesn't exist. Hassan is here. Hassan, that seat is good, right? Jose. Where? Oh, thank you. Thank you. I can't see a damn thing with my glasses off, but then if I put it on, then I fog up. Did I tell you the rumor that October we're going to be optional masks? Yeah, that's the rumor. I'm praying that it happens. So, Wen Cooney, nice. Did I mess you up with the room today? No, you got my email, right? Yeah. Chris, nice. Ralphie. Jorge, nice. Benjamin here. Try not to miss classes. I know. It really. I mean, I'm recording, so if you're sick, you know that you'll have the recording. If you got a job interview, you know what I mean. There's lots of good reasons to miss class, right? The worst thing is to not come to class when we have a test. because you go, oh, I'm going to fail it. Well, guess what? Now you have a 0 instead of a 30. Get the 30. It could help, okay? Johan, say, nice. Tavon, nice. Leandro, nice. Francisco, gotcha. Emmanuel, nice. Brian, yeah. Sina, nice. You know what I like on my corn on the cob? Pepper and lime. Try it once. It's pepper and lime. Oh, it's good. I'm telling you, it's good. Ivan. Thank you, Ivan. And Jason. Nice. Did I miss anybody? Great. Have a great day. See you next week.